Okay, so what I wanted to do today was play with this LCD display and try to get it to do a countdown. So here's the circuit, and I got the program working. So I think that we'll go back to the beginning with a sketch. So sketch out this circuit so you can see, and then we'll go over the program and then come back and rebuild this. And this little piece here that we're working with, this is from Radio Shack. It's an LCD display, and there's the model number. It's ELS321HDB, and it's like, I don't know, a couple dollars from Radio Shack. So let's start with drawing out this circuit, which is generally the way I like to start doing everything. I'm going to go ahead and start with the pins on here. If you have a circuit like this, any sort of IC, if you just type in the model into Google, you'll get something called a data sheet, and that's going to give you a pinout, and that will tell you what each of the legs on this little guy is going to do. So this is an example of what you get when you type in this part number. You get your data sheet, and then from there you can get the pinout. So it's pretty necessary to actually have the pinouts on these guys. But I'm going to go ahead and draw it the way that I have it. Alright, so there's our display, and this is defined as 7 pins on each side. So we have pin 1, 2, 3 is empty, so then we have 4, 5 is empty, 6, 7. So what I mean by that is, like, there actually is not a pin there. But you can see on the spacing on the chip how it kind of looks. So then this one is 8, and that's 9. And then down at the bottom we have 14, and we have 13. Okay, and these each correspond to different segments that light up on the screen. Okay, so if you look up your data sheet, you'll find that pin 4 goes to a common ground. So I'm going to go ahead and just draw pin 4 going to ground outside of there. Now one thing I'm going to have to do is I'm going to have to draw, hopefully it will be clear. Okay, just to make things simple, I'm going to draw the Arduino board down here. I once again just used pins 2 through 8. 7, 8. Okay. And since this is just an LED, and we don't want too much current going through it, I went ahead and popped in a resistor there, R1, and R1 equaled 560 ohms. No real reason for that, I just had a 560 ohm resistor lying around and that's what I wanted to use. Okay, so pin 1, and I'm going to draw it like this to show that those wires are not connected to each other. That one goes to 2, this one goes to 3, 4, 5, and we'll just have to draw more crossing wires. 6, and then 13 I didn't connect to anything. That's just some dots there. But 14 I did. And that goes to pin 8. Oh. I knew I was missing one. There is a pin 10 here as well. I did not use it. Pin 10 and pin 13 are the decimal places. And perhaps if we were putting them all together, I would use them. But since I'm not, I didn't bother. Okay, so that's it. That is the circuit diagram. These are LEDs. They don't take a lot of power, so we don't actually have to power the board with 5 volts or anything. I mean, it's getting enough current just from the board itself. Okay, now each one of these, so there is a segment on this for what each one of these lights up. So I'm going to draw it in as we go. So pin 1 lights up this segment. So that one is pin 1. Okay, I guess it's kind of confusing when I say pin 1, but that arm of the chip, the upper left corner pin, on the data sheet they call it 1. That one lights up that segment of the LED. And that's going to Arduino pin 2. So Arduino pin 3, maybe I'll write in what the Arduino pins are. So these would be the Arduino pins. I'll just call them A2. But this is kind of arbitrary because this just pertains to our circuit. That's A3. The next one is this guy. That's Arduino pin 4. And then this part is Arduino pin 5. This one is Arduino pin 6. Arduino pin 7. And I'm sure you can guess what the last one is. It's a big mystery here. It's that, and that is Arduino pin 8. So I hope that makes sense. So each segment is mapped to a certain Arduino pin. And we can go ahead. That wasn't what I wanted to do. Save this diagram, because that's, what I usually prefer to work off of is a diagram. I mean, I usually like to draw out the diagram first and then start messing around with it. So that's our circuit. Now let's go over the code. Okay, so this is a data sheet. I just wanted to show the data sheet really quick for this particular circuit. Even though, to be perfectly honest, I didn't really use it. The only thing that I looked up on the data sheet was where the cathode was, because I wanted to know which one I could hook up to ground. Then I just wrote a really simple Arduino code, where in that code, basically what I did was just, declare, say that the LED pins that I was going to use, the 2 through 8, and then in the loop, the main loop, just had it turn them all on. So it displayed a number 8, and then I just sat there and, physically took the wires in and out, and then until I got the numbers that I wanted to display. But data sheets are very, they're going to be necessary when you start working with ICs regularly. Okay, so this code, this is a code from a website. I had to look up this because I'm not a programmer, so I didn't really know how to. I was trying to just hammer it out, and that just didn't work. So I'd actually learn about a couple new Arduino functions. But if you like, you can just look up this code right here. The problem with this code, and for what I did, is that this part here is not does not correspond to any numbers the way that I did my pinout. So maybe if you actually read the page, which I kind of didn't do, it would give you your own diagram to make these pins work. I mean, I guess it makes, you could see this one's 9 and stuff, but you'd have to actually physically wire those. And my physical wires, I believe, are like, actually they're not entirely back. Like one row's like this part's backwards and this part's like switched. Yeah, so I just did it again. And then there was some other stuff that I cleaned up. I don't know why it has a dot in there. I just don't know. So I just didn't do that. And yeah. But everything else I kept the same just because I don't know how it works myself. Which is not a position I like to be in. I like to have the code be all stuff that I understand. Okay, so the first thing I did in mine was I defined integers as the LED pins that we're using, because I've done that before. And then I found out from the other code that there's a thing like this one. We're declaring these to be integers. Now I can also declare something to be a byte, which is pretty cool. So what I have is number digits, and I have 10 digits and 7 pins, 7 segments in the, so the LED display is 7 segments. So those are the 7 segments of the LED. Each segment of this LED display corresponds to another pin. And then, before, if you watch the other videos, I was saying high or low to turn the LED on or off. Well, it turns out that, oddly enough, in Arduino, you can just do 1 or 0. So I mean, I was doing 0 before, but yeah, you could just do 1 or 0. So for the digital, right? For analog, right, it is a little bit different. But so what I have here is the pin 2 on, pin 3 off, pin 4 on, pin 5 on, pin 6 on, pin 7 on, and pin 8 on. And if we look back at our sketch, we can see it says everything on except for pin 3. All right. And Arduino 3 is this one in the middle, so that makes a 0. So that's the 0, and then the code just goes so on through 0 to. Okay, we can zoom in a bit on this code here. So those are all the numbers, and I suppose if I was being good, I would actually write a comment for what each one of these is, because then, you know, we know. Oddly enough, I got this map right the first time, which was surprising. Okay. The reason I wrote it in a column was so I was afraid I would skip a digit. So when I have it in a column, it was nice. I could see that I was always getting 7 characters in there. Okay, now the section of the code that just runs, I did what I did in all the other ones, where I just say for integer I equal to 0, less than 8, and then increasing by 1. I want the pin mode to turn on those LED pins for each one for an output. That's just because, I don't know, I'm too lazy to type it 9 damn times. Okay, now here, they did this in the, other code from the website. And I thought this is something I'd probably want to do in the laser tag code too, which is write a different function just to separate it into functions. So this is a function that I called numbers write. So writing the numbers, and we can use this nice built-in thing that's bytes. So it's calling on something like this, and it's going to call them digits. So we're saying that I want these numbers to write bytes. So instead of taking 1 LED input at a time, it's going to take 7 at a time. So it's going to take that byte instead of just the output, 1 output, which is a lot nicer. And then that's going to be a digit. And then I say that I'm starting with pin number 2. So that means that this is corresponding to pin 2, and then it knows to go up in pins from there. To be honest, I don't know what would happen if we didn't have our pins in order. So yeah. Or say if you skipped number 9 or something. Not sure. I didn't try that. Okay, then we have a for function or loop, or for loop in this function. So for byte, and then this is something that I defined. This could be, before I used we could actually just call this in. But since I was copying somebody else's, I was afraid if I didn't copy it right, then it wouldn't really work out. Okay, so this is just a number for a byte number, not before we had integer I. This is for byte. Segment count 0 to segment count 7 to plus plus. So that's counting from this all the way up to 7. We want to digital write pin, and then the number digits. That's this list here, numbers, digits, with the digit and the segment count, which we defined up here. And then we do plus plus each pin. So that means the pin is increasing by 1 each time. Okay, so that's just a function, but that's not telling the computer to do anything with it. It's not till we get to our loop that we're actually telling the computer to do something. So in this loop, now what it's telling the computer is that for the byte count equal to 0, byte count equal to 10 to byte count greater than 0, and byte count decreasing by 1 each iteration. So this is how it counts down. We want to delay by a second, and then we want to use this function, number function, numbers right function. So we say numbers right, and then count -1. So we just want it to count down. And then we delay by 4 seconds before the whole thing loops back up again. So let's go ahead and rebuild it on the board and make sure it works. Okay, so let's go ahead and build the circuit again. We got the diagram, got the code. To be honest, I usually do the diagram, then I will build, then I'll just plug it into the computer, do like simple versions of the code to make sure that physically everything's right, and then I do like maybe more complicated versions of the code. And I'm going to be continuing with this little guy to try to implement it into the laser tag thing. Okay, so one thing, if you're ever wondering why there's this bridge guy down the middle here, it's basically so you can do ICs. And you know, maybe to make things a little bit more clear, I'll put it up. Well, no, we'll just put it down here. We'll start at 10 though, just to make it a little bit easier to memorize. And so the thing is that these rows, like row 1 here is not connected to row 1 here, because otherwise we can't really plug it in here, because now these pins are connected to each other, which we don't want. So we just do it over the little bridge there. Okay, the first one on our diagram is 4 goes to ground. So that's 1, 2, 3, 4. 1, 2, 3, 4. I believe that's right. Okay. Actually, here. We're going to put it in 11, so then I can just plug it into 14. Yeah, I'm that lazy. Okay, let's connect our grounds to each other, and then eventually I'll put that into the ground on the board. Okay, so then pin 1 goes to Arduino pin 2. IC pin 2 goes to Arduino 3. Then 6 goes to 4. 7 goes to 5. 8 goes to 6. 9 goes to 7. And then our last one is going to be 17. Well, 17 on here is pin 14. So pin 14 goes to 8, and then let's connect the ground up here. And I still have that program loaded, so let's go ahead and reset, and there we go. It's counting down. I can go ahead and turn off the light. And there we go. So it counts down to 0, it waits 4 seconds, and then it starts over again. So that was relatively painless, even though I didn't know how to do the code on that. And now I'm going to try to implement this counter. So now that I got the counter working and I got the code for it, now I'm in a position where I'm going to start trying something a little bit more complicated with it.